Today we will be learning about trigonometric identities. First, we'll start off by learning about Pythagorean identities. And so one of the Pythagorean identities is sine squared theta plus cos squared theta equals 1. And so which is derived from the unit circle. And so what we can do to get the other Pythagorean identities is divide this entire identity by cos squared theta, and so we get the following: sine squared theta divided by cos squared theta plus cos squared theta divided by cos squared theta equals 1 divided by cos squared theta. So you're probably wondering, well, what is sine squared theta divided by cos squared theta, or how can we simplify that? For that, we will need our quotient identities, and then later on we'll be looking at reciprocal identities. So if we look under quotient identities, we see that sine squared theta divided by cos squared theta is equivalent to tan squared theta. Now let's move on. Let's look at cos squared theta divided by cos squared theta, which is equivalent to 1 because anything, can be reduced to 1 because anything divided by itself is equivalent to 1. And now let's look at 1 divided by cos squared theta. For that, we can look under our reciprocal identities, and we see that 1 divided by cos squared theta is equivalent to secant squared theta, so we can substitute secant squared theta into this expression, and we get the following. We get the second Pythagorean identity, tan squared theta plus 1 equals secant squared theta. And so now to get our third Pythagorean identity, we'll be doing something similar, but instead of dividing this entire Pythagorean identity by cos squared theta, we'll be dividing it by sine squared theta. And so we get the following: sine squared theta divided by sine squared theta plus cos squared theta divided by sine squared theta equals 1 divided by sine squared theta. And so sine squared theta divided by sine squared theta can be reduced to 1 because, once again, anything divided by itself can be simplified to 1. And so now let's look at cos squared theta divided by sine squared theta. And for that, we can look under our quotient identities, and we see that that expression is equivalent to cotangent squared theta. So we can substitute cotangent squared theta into this expression. And so now let's look at 1 divided by sine squared theta, and to reduce that, or we'll simplify that, we can look under our reciprocal identities, and we see that 1 divided by sine squared theta can be, or is equal to cosecant squared theta. And so we get the following: our third Pythagorean identity, 1 plus cotangent squared theta equals cosecant squared theta. And so now what we can do with these trigonometric identities is help us reduce trigonometric expressions that we encounter. So we'll have our Pythagorean identities here as a reminder, and our quotient identities as well as our reciprocal identities. So let's try simplifying secant squared theta minus 1 times cotangent squared theta. What we can do is look at similar characteristics in this expression in our trigonometric identities. We have a secant squared theta and a 1, and so we also have a secant squared theta and a 1 under our Pythagorean identities. So what we can do is rewrite this identity like so, and we get tan squared theta is equivalent to secant squared theta minus 1, so we can substitute tan squared theta into this expression. And so what we can do now is bring down the cotangent squared theta, and now let's try to simplify that. So to simplify cotangent squared theta, we can look under our reciprocal identities, and we see that cotangent squared theta is equivalent to 1 divided by tan squared theta. Now I could have also looked under quotient identities, because cotangent squared theta is also equivalent to cos squared theta divided by sine squared theta. But if I were to use this, then I would have to simplify tan squared theta, or I would have to further simplify that, and using this reciprocal identity would make things much faster. So we have cotangent squared theta is equivalent to 1 divided by tan squared theta, and so now what we have to do is multiply these two, and we get all of tan squared theta times 1 divided by tan squared theta is all equivalent to 1. So secant squared theta minus 1 times cotangent squared theta can be reduced, or will equals 1. Let's do another example. Here we have our trigonometric identities to look at. Now let's try simplifying 1 divided by sine squared theta times cotangent squared theta. And to get started, what we can do is rewrite the expression like so. I personally find that easier, so this is what I decided to do. Now let's look at cotangent squared theta. That's what needs simplifying, or simplifying. And so for that, we can look under 1 we can look under our quotient identities, where cotangent squared theta equals cos squared theta divided by sine squared theta. And so we can also look at our reciprocal identities and use cotangent squared theta is equivalent to 1 divided by tan squared theta, but then we would have to further simplify tan squared theta, and so that would be a little bit more work. So choosing this quotient identity would make things easier for us. So as you can see, we have sine squared theta times cos squared theta divided by sine squared theta. Right, we substituted this we substituted cos squared theta divided by sine squared theta into cotangent squared theta, and so we have this now. And so to solve for this, what we can do is get rid of the sine squared theta, those cancel out. And so now we're left with 1 divided by cos squared theta, and we can rewrite this expression like so, like this, right? And then we can further simplify that. We can look under our reciprocal identities, and we see that 1 divided by cos squared theta is equivalent to secant squared theta. Now, something to remember when you're solving for when you're simplifying trigonometric expressions is that you have to be creative, right? There are times when you have to rearrange some equations, and that can be a little bit tricky, but eventually you'll get the hang of it, and at times it could be fun even. But that's all that we have for today.